Welcome. We're going to continue our discussion on stoichiometry. Just bear with me on this particular problem in the video because this is pretty much everything you need to know about stoichiometry. As you can see, this is a fairly long problem. I didn't want to do this one video as 20 different videos and chop the content to a point where you start to not see the relationship. So I decided to do them all in one problem. Now, if you have paid attention to the words I say, then you probably would know I've said that one of the common ways stoichiometry is done is you typically have 2 to 3 reactants and they ask you to calculate how much of one of the product is formed. And that's generally the pattern, right? Before we actually get started, let's actually go ahead and balance. This is a fairly straightforward problem. And if you actually balance, you would see that it's all 1, 1, 1, 1. And I particularly picked this particular equation because, you know, this video is not necessarily about balancing the equation, but actually pushing the idea of stoichiometry forward. So I try to make the equation easier so, you know, we can actually get through this fairly quick. Now, if you notice the equation, the question, this is really what the question, where the question starts. This right here is more of a statement on what is reacting. This is actually where the real question starts, and it says, if 30 grams of benzene, which is this, and 65 grams of bromine, which is this, so this is 30 grams, and this is 65 grams, it's asking how much of this is produced. So basically the way you interpret the problem is you are going to compare this with this and this with this, okay? It may look very simplistic at this point, but again, in reality, it is very simplistic. So you're gonna start with the 30 grams of benzene first, which is 3686 or CC686, and that's your given information. And as always, you put a 1, and then, well, you don't use the mole ratio yet. Why? Because this is in grams. You have to first find a way to get to moles before you can actually put in the mole ratio. And how can we go from grams to moles? Remember I said you need to know the idea of going grams to moles. Well, you need molar mass, and the molar mass of the C6H6 is basically about 79 grams over 1 mole. Remember, I told you to write it this way. So we put the 79 grams on the bottom and put the 1 mole on the top. Now this is for the C6H6, right? Now we got to put the mole ratio for this compound, which is 1. So 1 C6H5Br, that goes on the top, and 1 C6H6 goes on the bottom. Why? Because we are trying to cancel this out. Now if you see that, we're able to cancel out the gram and then the mole of C6H6, which means we're left with moles of C6H5Br. We're going to do the same, except what information is going to change is we're going to start with 65 grams of bromine, Br2, and as always you put a 1, okay? And then again we are going to convert the grams to moles, and Br2 I believe is 79 times 2, right about, you know, 80 is 160, so yeah, you can also treat it as 80, so 160 grams over 1 mole. That's for Br2's molar mass, right? So we got 6 grams, so 160 grams goes on the bottom because we are trying to get rid of grams to moles, and this is for Br2, and the ratio of Br2 to C6H5Br is again 1, so 1 Br2 goes on the bottom, the 1 C6H5Br. Why are we doing the same? Because the question is asking how much of this is produced. So we are comparing this with this, this with this, and since it's 1 to 1, it's not a problem. Again, we are going to end up with we are going to stop at this point and actually calculate these numbers, because that's what would determine how the problem is going to go further. So 30 over 79 is, this is 0.379 moles, and this is 65 over 160 is 0.218. At this point, to actually produce how much refers to grams of how much of this produced, you have to determine which of these two is the smallest. Well, this is the smallest. I'm going to write actually smallest. You have to figure out at this point which is the smallest, means that is the limiting reagent. Remember I said we are going to learn a new word. This is limiting. So whichever one is the smallest is called the limiting reagent. Okay, and now all we're going to do at this point is take whatever the smallest number is, that becomes your given information. You put a 1 on the bottom and you multiply by, because how much is grams, to go from moles to grams, again we have to figure out the molar mass, and the molar mass of this is 72 plus 1 plus 80, that's about 81, plus 72, that's 153 grams over 1 mole. So when you want to go from grams to moles, you divide by molar mass. When you want to go from moles to grams, you multiply by the molar mass. 153 gram per 1 mole, and that's pretty much it. So 0.218 is 33.35 grams. So as I said, bear with me on this video. What I meant is it might appear longer, but because I want to finish the whole concept in one single video. So the areas that you need to pay attention are setting up the problem, getting to the moles of the same substance twice, figure out which one is the smallest of the two, that is physically smallest value. That smallest substance is limiting. So what is limiting? Is it Br2 or C6H6? This is not the limiting. This is just the product. Limiting is actual reagent that led to the small value, and that would be Br2. So I'm going to write it here. Br2 is limiting. Okay, very good. Oh, sorry. Okay. All right, we're done with about 33% of the problem. And the second part of the question is it's asking for percent yield. That's the second term that I said to you that we will learn. I said 3 things we will learn. One is mole ratio, which we've already learned in the previous video and in this video. We learned what is limiting right here. And then we have to learn percent yield and then learn excess. How do we calculate percent yield? Very, very simple. Whatever you calculate, okay? Actually, I'm going to change this to probably about, say, 20 grams, okay? So if 20 gram of bromobenzene is actually produced, what is the percent yield of the reaction? Well, this is the theoretical yield right here, okay? This is theoretical yield. This is the actual yield. You can see it's actually produced. So percent yield is actual over theoretical times 100. So that is, actual yield is 20 grams. You may now wonder why I changed it from 50 to 20, because, you know, I made up this problem. And if I had put 50, your percent yield would be way too high. Okay, it's unrealistic. So this is my theoretical, this is my actual, times 100% would be, so it's basically 20 over 33.3 times 100 is 60%. Now, this part of the problem cannot be achieved if you haven't got the top portion right. Now, the last portion, the last term that you want to know is calculate the amount of excess left. And that is how you determine it is, well, you know the moles of, so this is the excess, right? So in other words, your benzene is your excess, right? So C6H6 is excess, right? So how do we find the amount of excess left is, you take the 0.379 moles and subtract it from 0.218 moles, okay? That will be 0.379 minus 0.218 is 0.161 moles. And that corresponds to the amount of benzene that's left, right? So this is how much benzene is left after the reaction is complete. So again, you put a 1. You want to go from amount refers to grams. So moles to grams again means we multiply by the molar mass of benzene, which is 78 grams, is it? Yeah, 79 grams. So over 1 mole will be 0.161 times 79 is 12.71 grams. What are we really saying is, you started with 30 grams of benzene, of which 12.71 gram is left unused. And this is all there is to stoichiometry. I know this video might be the longest of all the videos I've made, but then that's because I'd rather have you watch one video multiple times than watching 20 videos multiple times each one. That's going to cost more exhaustion on your part, and it's just going to take more time. So what are the things I want to drive from here is, you need to know how to use the mole ratio. You need to know how to balance. You need to be able to determine which is your limiting reagent, which is your excess. You need to be able to determine the theoretical yield and calculate percent yield, and then calculate the amount of the excess left. If you can literally do this problem in any bits of pieces I ask you, then you really know your chemistry. All right. With that said, I have 2 more problems, but they're very, very simple. So it's going to take actually a lot less time than this one particular video. All right. So stay tuned.